In this video, I'm going to show you how to solve three-term quadratic equations by factorization when the leading coefficient is not plus or minus 1. So here we want to solve the equation 2x squared minus x minus 3 equals 0. And how we've been doing this previously is we've been factorizing that left-hand side expression equal to some factor x plus some number times another factor x plus another number equals 0, and then just using the zero product property to set these two factors equal to 0. But there is an issue here. That issue is that this isn't going to work because it's not going to be equivalent to this original expression here. X times x makes x squared, but we have a 2x squared here. So this approach here is no good. What do we do instead? What we do instead is we factor a bit of a different way where we split up this middle term. So our first task here is we want to rewrite this expression as 2x squared plus some number times x plus another some number times x and then minus 3 that equal to 0. And now we're going to impose two constraints on these blanks. These blanks must, well, first of all, the blanks must add to the original coefficient on the x, -1. Blanks must add to -1. Second of all, in order for this new expression to factor nicely, we have to include one more constraint, and that is that the blanks must multiply to the product of the leading coefficient and the constant here. So the blanks must multiply to 2 times -3. So they must multiply to -6. Okay, so how do we figure out which two numbers satisfy these constraints? Well, maybe think about factors of 6 that are 1 apart. That way, when we make one of the factors negative, it'll multiply to -6 and add to -1. So think about factors of 6 that are 1 apart. Factors of 6, well, clearly not 1 and 6. Those aren't 1 apart, but 2 and 3 are 1 apart. Okay, so should we make 2 negative or make 3 negative? Well, they have to add to a negative number, so we should make the bigger 3 be negative. So we'll choose 2 and -3. Those multiply to -6 and those add to -1. So 2x then plus 2 here and -3 here. Okay, so now we've got an expression that is equivalent to the original expression, but now we can factor this nicely. First of all, let's just factor the first pair here, 2x squared plus 2x. What are common factors to that? Well, we've got a 2 in both of those, and we've got an x in both of those. So pull out a 2x, and what do we have left? Well, 2x times x makes x squared, and then 2x times 1 makes 2x. Okay, do the same thing with the second pair of numbers. So plus what's factors out of -3x minus 3? Well, there's a -3 that factors out, -3, and that looks to be about it. So x plus -3 times -3 times x makes -3x, and then -3 times 1 makes -3. And look at that. Now both of these terms have a common factor, x plus 1. So we can just factor out an x plus 1 from both of these terms and it'll factor nicely. We'll just have a 2x and a -3 and factor out that x plus 1 equals 0. Bam, there we've got it. It's factored and we are finally ready to apply that zero product property. So we can have 2x minus 3 equals 0 or x plus 1 equals 0. Let's figure out this first. 2x minus 3 equals 0. That means 2x equals 3, which means x equals 3/2, or x plus 1 equals 0, meaning x equals -1. So putting this together, we have the solution x equals 3/2 or -1. And there we go. Those are the two solutions to that quadratic equation. Alright, so how about this next example? We want to solve the equation 9x squared plus 33x plus 30 equals 0. And to solve this, we're going to use the same method as in the last example. But this time, there's one thing that we can do right off the bat to clean up this equation a bit. Right now, it consists of kind of big numbers, and that'll make the computations a little bit harder to do as we factorize this. But you'll notice that all of these numbers, 9, 33, and 30, they're all divisible by 3. So we can go ahead and divide everything by 3 to clean up this equation, make the numbers a little bit smaller while maintaining whole numbers. So first of all, divide by 3, and then we get 9 divided by 3, that's just 3, so 3x squared, then plus 11x, then plus 10 equals 0. So here we've got an equivalent quadratic equation with the numbers a lot lower, a lot nicer, and now let's go ahead and split up that middle term. So again, writing it as 3x squared plus some number times x plus another some number times x plus 10 equals 0, where we impose the following constraints. The blanks must, first of all, they must add to that middle term 11. That will ensure that it's really just the same expression rearranged a little bit. So blanks must add to 11. And then the other constraint, so that our new expression will factor nicely, is that the blanks must multiply to the product of the leading coefficient and the constant. So multiply to, what is 3 times 10? That's 30. Multiply to 30. Okay, so let's think. What two numbers multiply to 30 but add to 11? Well, let's think factors of 30. 1 and 30, those are too big. They don't add to 11. Let's go lower. How about 3 and 10? Those add to 13. We're getting closer. What else? What else? How about 5 and 6? Those multiply to 30, and those add to 11. Great, so it's got to be 5 and 6. Put 5 and 6 in those blanks, and now we'll go ahead and factor each of these pairs individually. The first pair, what is common to 3x squared and 5x? Well, there's an x in both of those, so factor out an x. X times what makes 3x squared? Well, x times 3x makes 3x squared, and then plus x times 5 makes 5x. All right, moving on to the next pair here, 6x plus 10. What's common to both of those? Well, in 6 and 10, those are both even, so we can factor out a 2. Factor out a 2. 2 times what makes 6x? 2 times 3x makes 6x, and then 2 times what makes 10? Well, 5. All right, so that's equal to 0, and here we go. We've got a common factor in both of these terms, 3x plus 5, so we'll factor out that 3x plus 5 and just get the product x plus 2 times 3x plus 5 equals to 0, and now we can just go ahead and apply that zero product property. So x plus 2 equals 0, or 3x plus 5 equals 0. If x plus 2 equals 0, then x equals negative 2, and if 3x plus 5 equals 0, then 3x equals negative 5, which means x equals negative 5 thirds. So putting this together, we've got two solutions, x equals negative 2 or negative 5 thirds. And there we go. These are the two solutions to that quadratic equation. Great, so now we know how to solve quadratic equations by factoring even when the leading coefficient is something other than positive or negative 1. In the future, we'll learn even more ways to solve quadratic equations, such as completing the square and using the quadratic formula.